How are ceramics made? You have seen the preparation of ceramic tiles in previous video. Did you get any clue? Here we give you another diagram. It shows one method of preparing ceramic pot. The raw material is in tiny particles. It mixed with some water and formed in a desired shape by mold. It's called a grain body or a grain ceramic. In this step, the formed grain body is still soft, without any strength. Finally, it's the firing processing, or called sintering processing, make a grain body to the ceramic tiles or pots. That's the traditional processing. With the continuous improvement of technology, we summarized the general step in processing of ceramic in the following diagram. And this diagram is also the outline of this video. For polycrystalline ceramics, we typically process ceramics into useful shapes, starting with ceramic pounders. The difference between traditional ceramics and advanced ceramics starts with the raw pounder. Mineral silicates such as clays, silicon, alumina natural ore are the principal raw materials for traditional ceramics. On the contrary, artificial refining chemical raw materials are used as pounders for advanced ceramics. They are usually chemically simpler than traditional ceramics. For example, pure alumina particles for alumina ceramic component, and pure silicon carbide particles for silicon carbide ceramic parts. Another one, pure silicon nitride particles for silicon nitride bearing ball. One of the most important quality control parameters is the ceramic particle size and size distribution. The particle size can help define the time and temperature required to obtain full density during sintering period. The finer particles are, the shorter sintering time requiring, due to their high surface area. The particle size distribution and shape are also important for the final quality of the ceramics. You may be wondering how those artificial refining chemical raw materials are synthesis. It's another word, and I have a long story. We won't go into the detail. Following this diagram, you can dig deeper later if you are interested. Question: can pure pounders themselves be directly molded? The answer are negative. This is where the second step is necessary. A pounder is a collection of thin particles. Ceramic pounder consists of ceramic particles and additives that improve a pounder's compaction and sintering. Additives include a bedding agent to hold the pounder together after compaction, and a release agent to enable a compact component to be easily removed from the compaction die. We know that the particle size and its size distribution is important. The significant features and properties of ceramic pounder are the particle composition, the amount of dye release agent and binder, and their composition. A ceramic pounder is usually prepared by crushing, grinding, separating impurities, blending different pounders, drying, and spray drying to form soft agglomerates for shaping. Ball mills are used for grinding materials such as ceramic pounders. Grinding can be carried out wet or dry. A wet grinding implantory ball mills is showing now, and first grinding balls were put into jar. Then the ceramic pounders were also poured into the jar. Their volume ratio needed to be controlled. Mix sample and grinding balls carefully. Choose a dispersant liquid which does not change the sample property. Then fix the jar into the ball mouth. Start grinding. After milling for 35 minutes and 500 rpm, open jar carefully. And use a sieve to separate a sample from grinding balls. Finally, fitness particles of about 0.7 micron are obtained, which initial particle size is about 1 millimeter. Speed drying. Speed drying is a method of producing a drying powder from a liquid or slurry by rapid drying with a hot gas. This is a preferred method of drying a wide variety of materials, such as the food, the medicine, and the ceramic powders, which require extremely consistent thin particle size. The process begins when a liquid or slurry product feed is passed through a special nozzle. The nozzle disperses the liquid stream as a mist of thin droplets into a heated gas atmosphere to facilitate the drying processing. As the product feed is dispersed into the drying chamber, the droplets rapidly dry as the liquid evaporates. The dried particles fall through the drying chamber for collection for further processing. The shown spray-dried ceramic powders are all regular spheres. This is beneficial to molding later. The ceramic powders are prepared now. What's the next? The next step is to convert the prepared ceramic powders into a desired shape. That is the third step of ceramic processing. There are different techniques can shape the ceramic powders to the grain body, such as compaction, tape casting, extrusion, slip casting, and injection molding. A grain body just mentioned is an object whose main constituent is weakly bonded ceramic powder before it has been sintered or fired. It comprises a mixture of the ceramic particles and various organic or inorganic additives. One of the most cost-effective ways to produce thousands of small, simple shapes is compaction. Many electronic and magnetic ceramics, cement, and other materials are processed using this technique. Thin particle is in the form of soft agglomerates that flow and compact well. The powders are then compact. The density tends to decrease among parts height as the distance between the packing punch and the die increase. To produce more uniform density, thick parts are compacted by a set of upper and lower punches. Cold isostatic pressing is another compaction technique. Isostatic pressing is similar to uniaxial pressing in the requirements for the powder and in the general step of the press. But there are several important differences. First, the compaction takes place under a hydrostatic conditions. That is, the pressure is transmitted to the part equally in all directions, or very nearly equally. Second, the powder is loaded into the flexible mold, then rigid die. We are watching an example. First, the white ceramic powders are loaded into a rubber mold. The mold is sealed well and put into the vessel for cold isostatic pressing. The pressing cycle is initiated, and the pressure is applied in a pressure vessel by a liquid. The vessel automatically seals and exhausts. Once a sample has been pressed in a cold isostatic press, it must be removed from the mold. Finally, a cold isostatic pressed circular tube as a grain body is formed. Both uniaxial pressing and isostatic pressing use dry ceramic powder. We will go forward to the next technique, slip casting. Slip casting uses liquid clay. Slip casting is a ceramic forming technique for pottery and other ceramics, especially for shapes not easily made on a wheel. In slip casting, a liquid clay body slip is poured into a plaster mold and allowed to form a layer, the cast, on the inside walls of the mold. It gives very precise and consistent shapes. A layer is formed because the porosity of the plaster mold absorbs the water in the slurry. That causes a deposit of material to form on the inner wall of the mold, taking the shape of the mold. The thickness of this skin or layer is proportional to the forming time. Now let's look at the actual demonstration. Compared with manual modeling, slip casting is a common technique used for commercial mass-produced fine pottery and porcelain. Tape casting. Tape casting is a method for fabricating thin layers of ceramics, or most any other material that can be prepared as a liquid slurry. Ceramic tips are important components. Many commercially electronic packages based on aluminum substrates and millions of capacitors in our cell phone are made use this type of tape casting process. The starting point for the tape casting process is the pounder. In general, the pounder is very thin, with maximum particle size of 5 micrometers. This is the active component of the fin product. And the other contents, such as binder materials and solvents, have to be compatible with the pounder. A slurry is cast with the help of a blade onto a substrate. A simple tape casting process is seen here. The slurry is poured into the tank. With a uniform movement of the substrate, one tape casted thin layer is formed. In the follow-up process, the green tape must be dried and subjected to sintering. Extrusion. In the previous video, we have seen the green body of tile is formed by extrusion techniques. The clay is fed to the extrusion machine. Inside the machine, the vacuum removes all air from the clay mix, and a large screw presses the clay through a metal die, and a sheet of material that will form the tiles is punched out of the machine. This process is known as extrusion. To begin the extrusion process, high-quality raw materials are blended to create a homogeneous mixture. Next, liquid is added to the raw material mixture or poured into a conical hopper. The mixture is then transformed into a paste-like substance. The substance is fed into a screw extruder and through a honeycomb die, which creates thousands of tiny parallel channels. Finally, each finished piece is cut to a special length, meeting all manufacturer's requirements. We are showing some extrusion-formed ceramic parts after they have been well sintered. Injection molding. Injection molding is a popular manufacturing method for plastics, and it's also applied for preparing the green body of ceramic materials. Ceramic injection molding offers a near-net shape, large-scale production of ceramic components with complex shape. What you are seeing now are all ceramic inject molded industrial products and consumer goods. The basis for the ceramic injection molding is a so-called feedstock. The feedstock consists homogeneous mixture of ceramic powder. Ceramic powder is mixed with a thermoplastic plasticizer and other additives. The mixture is then granulated. They are formed into uniform pellets. These pellets are then liquefied and forced into a mold. The polymer, such as the binder contained in the injection molded ceramic, is burning off. And finally, the rest of the ceramic bodies is centered under a high temperature. When it's taken out of the furnace, the designed ceramic part with complex shape is obtained. Up to now, we have introduced the common forming methods for ceramic materials. Next comes a more important step.